Hi, I'm Ben Canning, and this microlecture is going to be on inertia and Newton's first law. As always, you need 3 or more bullet points worth of notes, a 1 to 2 sentence summary, and to do your follow-up questions on Google Forms. So, inertia. There's lots of applications of it. Mainly, it can be kind of comical, such as this guy's inertia is keeping him moving while his bike is stopped by these tires here. And what we're going to do in this microlecture is explore the idea of inertia, what it means, how to measure it, things along those lines. But first, let's start with a similar scenario. We've got a truck, it's carrying some boxes. Let's pretend the boxes are decently heavy, but those boxes aren't strapped down. So the truck's cruising along the highway, and then it sees something and it slams on the brakes. What's going to happen to those boxes? Think about your answer for a second. Well, hopefully we all realize that those boxes are going to go flying forward, especially those ones on the top where there's like nothing there to stop them. And the reason why they do this is because they have inertia. So inertia, for kind of a basic definition of it, or basic idea of it, is it's an object's resistance to changes in motion, meaning those boxes are moving and they have inertia because they have mass, and as a result they want to keep moving. Like, they don't want to stop unless you actually force them to stop with a force. So that's what we mean by this idea of inertia. It's the resistance to changes in motion. And if we think about, let's say, this big sumo wrestler here and this little kid, obviously the big sumo wrestler, much harder to get him to move, or in other words, much harder to change his motion. As a result, we would say he has more inertia. Little kid, much easier to change his motion, and so we would say he has less inertia. Which brings me to the point of we measure inertia with mass. And also the idea that that's actually one of the official or technical definitions of mass. I know we say it's like how much stuff there is in an object, but a more technical definition, one of 2 of them, is this idea that mass is a measure of an object's resistance to changes in motion, or in other words, resistance to acceleration. This is known as the inertial definition of mass, and there's actually one other definition of mass that we'll cover later on, but I digress. The main point here is mass measures inertia, and inertia is an object's resistance to changes in motion. So this is really what Newton's first law is based on, and we're going to unpack the idea of the first law right now. So Newton's first law states that every object continues in a state of rest or of motion in a straight line at a constant speed unless it is compelled to change that state by forces exerted upon it. It's not exactly the most friendly language, so let's break that down and figure out what it actually means. So here's my interpretation. This isn't like the official way of stating it, but it's what it kind of means in normal everyday language. Which is, Newton's first law states that if all forces on something are balanced, in other words, they cancel out, or the net force is 0, then it's going to do one of 2 things. It's either going to remain at remain at rest, if that's how it started, or if it started off moving, then it's going to remain at a constant velocity, assuming that's how it started. So I like to think of this as the kind of couch potato law, namely that things are lazy and they basically like to keep doing whatever it is they're doing. Whether that is remaining at rest, so basically if something is sitting still, it's always going to stay that way until force is applied. Not a big surprise there, but the other one that's a little more surprising is this idea that something's going to continue at a constant velocity because that's what it was doing, because of its inertia, because of its mass, and therefore giving it inertia. If there is no net force, or all forces are canceled out, in other words, then whatever it's doing, it's going to continue to do that. So if it's already moving, it's going to continue to move in a straight line at a constant speed forever, which is kind of weird. That's strange to think that something without a force on it will continue to move in that same direction for forever. So for example, if you take a rock and you're in outer space away from all planets where there's no gravity, no air, nothing to kind of slow that rock down, you throw it, it's gonna keep going forever and ever and ever, or at least until it runs into something or another force is applied to it, gets near a planet, gets pulled in, something like that. But otherwise it's going to go in a straight line until it basically hits something. So that's Newton's first law, the idea of inertia, and that's it for this micro lecture. 3 or more bullet points worth of notes, 1 to 2 sentence summary, and do your follow-up questions on Google Forms.